Today we will learn how to calculate equivalent dielectric constant. Equivalent dielectric constant. What is the meaning of equivalent dielectric constant? Let it is the capacitor. Air. Only air is present within the capacitor. No medium, no dielectric medium. So capacitance equal to epsilon naught A by D. D is the distance of separation. A area of plate. D is distance of separation between the two plates. These two plates are charged, means connected with a battery. Plate 1 is connected with positive terminal of the battery. Plate 2 is connected with positive terminal of the negative terminal of the battery. So now these plates are positive, this plate is negatively charged because connected with the battery supply. But the medium is air or vacuum, no medium. That is, capacitance is epsilon naught A by D. If you insert a medium, this is medium having dielectric constant K, then capacitance equal to epsilon naught K A by D. This is single dielectric. This is single dielectric K. Suppose polyester, oil, only one type of dielectric, so epsilon naught Ka by D, right? But our today's learning is if multiple dielectrics are present, then how to calculate equivalent dielectric constant. If multiple dielectrics are present, then how to calculate equivalent dielectric constant. Look at here. Multiple dielectric. This is the in distance of separation, total distance of separation D. Now it is divided D by 2, D by 2. This dielectric K1 is D by 2, distance of separation between the plates, and another dielectric distance of separation is also K by 2, D by 2, distance of separation is D by 2, dielectric is K2. So two types of dielectrics are inserted, plate 1 and plate 2. Okay, this third one is the separator. So two types of dielectric are within the two charged plates of the capacitor. Then how much is the equivalent dielectric constant K? Okay. So in this case, area of plate is constant. Area of plate. Area of plate is constant. What is divided? Distance of separation. Distance of separation. Distance of separation between the two plates 1 and 2 are divided. How much? D by 2 and D by 2. So there are two equally divided. Two types of dielectric constants are inserted. Then how much is the equivalent dielectric constant? Okay. You see, when you move from this X point, the charge will flow to the terminal Y through both the dielectric. They must go through dielectric 1, they must have to go through dielectric 2. So there is no alternate way. Charge cannot flow from X to Y through one dielectric. It must have to pass through two dielectrics. So this is a series grouping. This type of grouping, you imagine series grouping, because why series? Charge has to travel through both the dielectric to reach to another point. So when two capacitors are in series grouping, equivalent capacitance 1 by C equal to 1 by C1 plus 1 by C2. Here C epsilon naught Ka by D, you write in C1 epsilon naught K1, area is A, distance of separation is D by 2, epsilon naught K2, A, D by 2. In both capacitors, this is a capacitor 1, this behaves as a capacitor 2. This capacitor 1, area of plate is A, distance of separation between the two plates is D by 2. In C2 also area is A, D by 2. So you write in this way, then go for simplification. Epsilon naught A by D equal to D by 2 epsilon naught, and this is K. K1, you write this D to the top. You take this D to the top, D by 2 to the top numerator, epsilon naught A1K, here D by 2 epsilon naught K2 A. Clear? Just you go for simplification. Go for simplification. D by 2 comes to here. Denominator side is epsilon naught K by, numerator is D by 2. In this case, numerator is D by 2, denominator is epsilon naught K2A. So D by epsilon naught Ka, D by 2 epsilon naught K1A, D by 2 epsilon naught K2A. Right? Cancel D, all the parameter D is cancelled. Epsilon naught is cancelled. So A is cancelled from LHS and RHS. So 1 by K equal to 1 by 2 K1 plus 1 by 2 K2. Right? D, LHS, RHS D cancelled. LHS epsilon naught, RHS epsilon naught cancelled. A cancelled from LHS RHS. So 1 by K, take the LCM, 2 K1 K2, K2 plus K1. So K equal to 2 K1 K2 by K1 plus K2. This is the equivalent dielectric constant. When two dielectrics are inserted like this manner, this is dielectric 1, this is dielectric 2. This is the series grouping. So like this, if there are three dielectrics, 1, 2, 3, this is dielectric 1, this is dielectric 2, and this is dielectric 3, K1, K2, K3. Then equivalent is you go through like, comes to like. In this way you can calculate. 3 capacitors, 1 by C equal to 1 by C1, 1 by C2, 1 by C3. Series grouping of 3 capacitors. You have to calculate and put the value. Get how much is the equivalent dielectric constant, 1 by K. Okay. So equivalent in case of 3 number of dielectrics, while inserted in like this manner, series manner, then you have to calculate how much is the equivalent dielectric constant. Okay. Thank you.